Hello, Math 2 students. Are you ready to learn about the Pythagorean Theorem? The Pythagorean Theorem. We're going to change the study of what we're doing from every possible triangle to just studying right triangles. And right triangles have some vocabulary words that go along with their names. Every right triangle has two legs, and every right triangle has a hypotenuse, which is located opposite the right angle and is the longest side of the triangle. So what is the Pythagorean Theorem? When do you use it? And what is it used for? If a triangle has a right angle and two sides are known, then you can use the Pythagorean Theorem to find the unknown side. The Pythagorean Theorem probably looks familiar. It's c squared equals a squared plus b squared. But the important part to remember about this formula is that the hypotenuse is always the c squared side. And the a squared and b squared are always the legs of the right triangle. So now we're going to do these two examples. You might think at first glance that these examples are going to have the same answer because here two legs are 4 and 10 and here two legs are 4 and 10. But these problems are different. The triangle on the left, we're looking for the hypotenuse. Our x is on the longest side of the triangle. And in the triangle on the right, we're looking for a leg. The hypotenuse is one of the known sides. So since we know the hypotenuse is the longest side of the triangle, we know that this side has to be greater than 10. And over here, since the hypotenuse is the longest side of the triangle, we know that this side has to be less than 10. So here's the Pythagorean Theorem, and we're going to fill in the variables. Now notice, very important, that the c squared is always whatever's on the hypotenuse. So for c squared, we substituted x. And for the legs, because we're adding, it doesn't matter what order you put them in. So I have 4 squared plus 10 squared. Now I do the arithmetic, and I get x squared equals 16 plus 100. And then I add those, and I get x squared is 116. Now in order to solve for x, I need to take the square root of both sides of the equation. And when I do that, I get x equals plus or minus the square root of 116. Now I need to simplify that square root. So I need to figure out what perfect square goes into 116. And the answer to that question is it's 4. So 116 is 4 times 29. And as I simplify that, I get x equals plus or minus 2 root 29. Now, for Pythagorean Theorem problems, our answer is actually a distance, something that you can measure with a ruler. And there are no negative numbers on a ruler. So we can disregard the negative part of this answer and say that the length of side x, the hypotenuse, is 2 root 29. If we want to know that answer as a decimal, it would be about 10.77. But notice that that means it's the approximate answer because we had to round that off. The exact answer is 2 root 29. Now for this example on the right, we have the Pythagorean Theorem. We're going to fill in the variables. And notice again that the hypotenuse is always the number that gets filled in for the c squared. So we put our 10 there. We have a 4 there for one leg and an x there for another leg. Now we do the arithmetic and we have 100 equals 16 plus x squared. At this point, to get the x by itself, we need to subtract 16 from both sides. So I subtract 16 here, I subtract 16 here, and I get x squared equals 84. Now I need to take the square root of both sides of the equation, and I get x equals plus or minus the square root of 84. Now I need to simplify that. So what perfect square goes into 84 evenly? It turns out to be 4 again. So I break it up into plus or minus 4, root 4 times root 21. Then 4 is a perfect square, so that turns into plus or minus 2 root 21. And because we're trying to find a distance, we disregard the negative answer. We just say the exact answer for the length of this leg is 2 root 29. If we want to know the approximate decimal answer, that would be 9.17. Now we're going to talk about Pythagorean triples. And so we're going to start out with this triangle, which has a side that's 3, one leg that's 3, one leg that's 4, and we're going to use the Pythagorean Theorem to find the hypotenuse. So we have c squared, because we're looking for the hypotenuse, equals 3 squared plus 4 squared, because those are the legs. Now that'll be c squared equals 9 plus 16. We add the 9 and 16, we get c squared equals 25. Now we need to take the square root of both sides, and we'll have c equals plus or minus 5, because the square root of 25 is 5. Now again, we know we're talking about a distance, so the length of our hypotenuse is positive 5. Now this is called a Pythagorean triple because both of the legs and the hypotenuse are positive integers. There's no square roots, there's no decimals, there's no fractions. This side is 3, this side is 4, and this side is 5. That's a special case. And this is a way to solve many Pythagorean theorem questions without having to actually use the Pythagorean theorem. If you memorize that 3, 4, and 5 make a Pythagorean triple, then every triangle that is similar to that will also be a Pythagorean triple. So to start with, if we look at this triangle, we've doubled our side from 3 to 6. We've doubled our side from 4 to 8. So if we're looking for the hypotenuse is also going to be doubled from our original triangle, so our hypotenuse is 10. So 3, 4, and 5 is a Pythagorean triple, and 6, 8, and 10 is also a Pythagorean triple. Here's another triangle that's similar to the first one. If this has a side of 3 and we multiply it by 3, that'll give us a side of 9. If this is a side of 4 and we multiply it by 3, that'll give us a side of 12. If our hypotenuse was 5 and we multiply it by 3, then our hypotenuse will be 15. So a 3, 4, 5 triangle is the same thing as a 6, 8, 10 triangle, which is similar to a 9, 12, 15 triangle. If we take our original triangle and multiply every side by 4, this side goes from 3 to 12, this side goes from 4 to 16, and our hypotenuse is going to be 20. So every similar triangle that's similar to our 3, 4, 5 Pythagorean triple can be found by memorizing the 3, 4, 5 Pythagorean triple. So the next one, if we take our original triangle and we multiply every side by 5, we'll have a side that's 15, we'll have a side that's 20, and our hypotenuse will also be multiplied by 5, so it's 25. All right, so our first Pythagorean triple that you should memorize is 3, 4, 5, and when you memorize that Pythagorean triple, you will also know the answer to every 6, 8, 10 triangle, and every 9, 12, 15 triangle, and every 12, 16, 20 triangle, and every 15, 20, 25 triangle. So by memorizing these 3 numbers here, we can solve Pythagorean theorem questions with all of these different triangles. That's not the only Pythagorean triple that you should memorize. You should also memorize 5, 12, 13, and all of the similar Pythagorean triangles that go with it. So if you notice, these ones in red, they're called primitive Pythagorean triples. Those are the ones that you need to memorize. And then all of these are just a result of taking the primitive Pythagorean triple and multiplying it by a scale factor to get a similar triangle. The next one you need to memorize is 8, 15, 17. And when you memorize that, all of these Pythagorean triangles are similar to that one. And then the last one that usually people memorize is 7, 24, 25. And if you memorize that primitive Pythagorean triple, then you'll be able to solve problems with all of these different side lengths. So the 4 Pythagorean triples that you need to memorize are 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Now we're going to take a look at the converse Pythagorean theorem. The converse Pythagorean theorem and the Pythagorean inequality theorem are tools used to determine if the segments that form a triangle will form a right triangle, an acute triangle, or an obtuse triangle. And remember, not every 3 segments can form a triangle. We already learned that the 2 shorter segments have to add up to more than the longer segment in order to form a triangle at all. But if you know that your segments form a triangle, then this table right here tells you how to determine whether it's a right, acute, or obtuse triangle. So if the c squared or the hypotenuse squared is equal to the sum of the legs squared, it'll be a right triangle. If the hypotenuse squared is less than the sum of the legs squared, it will be an acute triangle. And if the hypotenuse squared is greater than the sum of the legs squared, it will be an obtuse triangle. So if we take these three line segments and we take their lengths and put them into the Pythagorean theorem, we'll be able to determine what type of triangle can be formed by those line segments. So to start out with, we're going to take c squared equals a squared plus b squared, but notice I'm not putting the equal sign in there because I don't know yet if they are equal. It might not be a right triangle. And so it's going to look like that, and then I fill in my variables. So the longest side is 12, so that goes where the hypotenuse would go. That's the c part of the Pythagorean theorem. And then my legs are 8 and 4 root 3, so I substitute those in. Now I do the arithmetic. 12 squared is 144, 8 squared is 64, and 4 root 3 squared is 68. Now I add the 64 and the 48, and I have 144 on the left and 112 on the right. So 144 is greater than 112. So on this problem, it turns out that my hypotenuse squared is greater than the sum of my leg, the sum of the squared legs. So this is an obtuse triangle. So if we put these segments together, we would get a triangle that looks like that has one obtuse angle. All right, Math 2 students, I hope after watching this video, you can use the Pythagorean theorem to find the missing leg or missing hypotenuse of a right triangle. I hope that you realize memorizing Pythagorean triples can help you solve many Pythagorean theorem problems without even having to do the Pythagorean theorem. And finally, I hope you see that the converse Pythagorean theorem and the Pythagorean inequality theorem can help you determine whether three segments that make a triangle form a right triangle, an obtuse triangle, or an acute triangle. Thanks for watching.